Piecewise Functions. Peace as Connor Sullivan. Wise as the Luke Lineberger. What's up? He's Peace and I'm Wise. Today we're going to be talking about piecewise functions. These functions are the best functions in the whole world. They're very hard though, so we're going to show you how to do them quickly and effectively, get the job done right away. Piecewise functions made of different pieces. This one has two. They can have more than two, but they at least have to have two. Our top one is x plus 1 with a domain restriction of x is less than 0. Our bottom one is x squared with a domain restriction of x is greater than or equal to 0. Now this x squared means it's going to be a parabola, so it's going to be U-shaped. It can face up or downwards. How we're going to go at this thing is we're going to graph it first. Peace. Graph it, please. Right now he's picking points for this x squared one. Parabola again, so it's going to be a U-shaped. He's picked 1, 1. 1 squared is 1. So x is 1, y is 1. It's also done 2 to get 4, negative 1 to get 1, negative 2 to get 4. Connect the dots, get your parabola. Great job, Peace. Now we're going to attack this top one here. First one he did is 0. 0 plus 1 is 1. 0, 1. You're going to graph these things exactly how they should be. This one is a linear function. This one's a parabola. Graph it to its rules. Connected lines, make it correct. Now the next thing that we're going to go off of, we're going to erase what's not in the given domain. So the domain restriction says it has to be less than 0. So that means that this part from here over can't be there. It can't exist. So we're going to have to erase it to show that it's not there. Now we're doing this because if x is greater than, then it doesn't fall in the domain restrictions, it's against the rules, then does not become a piecewise function. Now right here, we have a dot, or point, 0, 1, that is on 0. Now in this case, x is equal to 0, but x cannot equal 0. So we have to make it an open circle, telling that it can't technically be there, but that's how we graphed it, so we're just going to show you what it would look like. Now for this one right here, x has to be greater than or equal to 0. So that means from this side over, cannot be there. We're going to erase it. Make it look nice and pretty for your teacher. And now you have graphed a piecewise function. This is what your final piecewise function should look like. What's up? He's Peace and I'm Wise. We're here for Piecewise Functions Round 2. This is the second way to do it. Now right here we have nice piecewise functions. I'm going to show you why. We have two domain restrictions right here. Negative 2 is less than or equal to x is less than 1. Why it's easy is we can plug these numbers in as our x values to get our y values. We don't have to guess numbers. It's very easy, very simple. We also know that it's going to fit or be within the given domain. So right here we have x plus 3, domain restriction as negative 2 is less than or equal to x, less than 1. 2x plus 5, negative 3 is less than or equal to x, less than 0 as this domain restriction. So right here, plug in these points, make our graph. These are linear functions, should be easy to graph. Peace. Graph, please. Now you see, right here, he's going to make an open circle. Because technically, it cannot equal 1. Otherwise, there would be a line right here. But in this case, it does equal 1. So to show that it's there, but not technically there, because it can't technically equal that number, we're going to make an open circle. It's just the rules of piecewise functions. Connect it, now you have your first part of the piecewise function. Come down here now, graph this one. Now again, open circle, 0, 5. Technically, this cannot equal 0. But the line goes there, so we have to show that it goes there, but does not quite get to the open circle. Make an open circle, that's the rules, show how it's done. Right now here, we have your finished piecewise function. This is the easy way, this is the lucky way. Get it like this, you should be able to pound through it. That's the way to do piecewise function. Final result of the second piecewise function.
That's how you do piecewise functions. Piecewise?